Let's look at some examples of functions and mappings then. So the first one we want to look at is question 1. Now for question 1, it says y equals square root of x, and the x is an element of the real. So the second bit here is telling us about the domain, and it's telling us that our domain is an element of the real numbers, this r here being the real numbers. So any number which you know of, which is real, so that's what it's telling us there. Now the problem with that is that if we have positive numbers for root x, that's fine because they get mapped to some value of y. But when we have a negative x number, we can't square root a negative number. They're not possible. So this isn't a function in its current form. We need to convert it so that we only have a set of numbers that it's true for. And the way that we're going to do that is that we're going to restrict part of our real numbers such that x is greater than or equal to 0. So once it's greater than or equal to 0, it's then able to be it's now become a function. Okay, let's have a look at question 2 then. So question 2 this time we've got f of x equals 1 over x, where x is an element of the reals and x is between 0 and 12. So let's put 12, let's put 0 there. 1 over x is going to look like that, something along those lines. Now the good point here is that if you notice this bit here, that it doesn't include 0. Now 1 over 0 is not defined, it goes off to infinity, so that wouldn't be a function. But because it doesn't include that, every element in x is being mapped to a value in the range, so this is a one-to-one function, so that one's okay as well as a function. Let's look at this one here. This time we've got f of x where equals x plus 4, where x's domain is only 1, 2, 3. Now, because this is like discrete numbers, it doesn't include all the numbers in between, we're going to use these circles this time. So this time we've got 1, 2, 3 in our domain, and we want to find out what our range is. Well, our range would be plus 4 each time, so 5, 6, 7, and that would be our graphical form of f of x equals x plus 4. Because they're distinct values, we're not including everything in between. It's not an inequality sign like we had up here. Finally, we've got something called piecewise. So a piecewise function. And what happens with this is it's split into two parts. So if I read across, it's telling us that we've got a function x such that the function is x up till x is less than 2. So let's draw that in. So I'll try doing my best straight line. So it goes through 0, 0, and it stops at 2. Now you'll notice that it's x for when x is less than 2, but it doesn't include 2. So I'm going to draw an open circle there. It then says that x is a function of x squared minus 1, for where x is greater than or equal to 2. So when x is 2, you'll get 2 squared is 4 minus 1 is 3. So it's going to start from up here at 3. So this was at 2, this is at 3 now. And it's going to follow a quadratic curve from that point onwards. So we're going to get it getting larger very quickly. I'll draw over the top there in a quadratic form. So that's what we call piecewise. This is a function because if I was to draw a vertical line at any stage, there's always one intersection. So that went back to our definition up here that a mapping is a function if every input has a distinct output, so only one output that it goes to. In this case it does, because even at when x equals 2, it's only this value here which is a function of. So that's some examples of functions and mappings for the course.